Okay, in this lecture series we're gonna see about assembly language still in microprocessor system. Before we begin, we have certain stuff to remember first. The first is this. So we have A, which is accumulator, which stands for accumulator. Then we have flag, and then we call this pair, we call it as PSW. Okay, so we have A as a 8-bit 8-bit storage, and flag stands for 8-bit too. Then the pair, we call it as PSW. Then we have register B as a single register which has 8-bit, and the pair is B, C, D, E, H, L. Then we have stack pointer and program count. Program count, as I said, if we have move A and move B, and the currently is move A, the program count will show the next instruction in which byte. And a stack pointer is the location where it's referring to. Now for memory, we have 00000000H till FFFFH, which is equivalent to 2 byte, or what we call as 16-bit memory. For IO, we have 00 to FF, which stands for 1 byte, or what we call as 8-bit memory, because these stand for A0 till A15, whereas this is AD0 till AD7. And then we have the basic, we need a basic knowledge in decimal to binary to hexadecimal. Okay, so this basic knowledge need to be familiarized. I hope everything would be okay. For example, if we have 10 is equivalent to 0 0 0 0 1 0 1 0 in binary, which is also equivalent to 0 AH in hexadecimal. So you need to know the difference and so on. And for the flag, so this is the flag as said. This is for the sign, this is for the 0, this is don't care, this is for the auxiliary carry, which means that if we have as such from D3 to D4, if there's any carry, this will be reflected. This is don't care, parity if even number of ones, and don't care and carry, which is the carry for D7 and so on. Now in assembly language, we have this set of instruction, and we will be given an appendix called 8085 instruction set. In that instruction set, you will be given the amount of bytes, the translation to hex code, and sometimes they will be mentioning about which flags are going to be affected due to the instruction being executed. But as engineers, we need to know the basics of the assembly language without the instruction set. Even though the instruction set is given, we need to know how to use the instruction set in order to understand what's going to happen with the specified assembly language that we are going to use. So assembly language, as said, is in between our daily programming language and also hex code, something that we need to know. Or it's near to RTL, register transfer language. Now the first and foremost is data transfer instruction. So in data transfer, we have as such. Now this is immediate immediate data transfer. So immediate data transfers, we have move immediate, register data 8. So what's going to happen is move immediate, this data is going to move into register. So this is the instruction, this is the destination, and this is the stuff that going to be in the destination. For example, move immediate A 0AH. So 0A, it's gonna be in A. Okay, that's what gonna happen. Now move register means register either B or C or D, which is a single register, whereas RP means is a register pair. It could be B, C, D, E or HL. It doesn't involve PSW yet. PSW is specifically for push and pop, which we will be discussing later on. Then move register 1, register 2. What does it mean? Move A, B. So the B's value is going to be into A. Then we have a direct transfer, which means load accumulator, store accumulator, load high low, which is memory, store high low, which is memory. Load means we're gonna load the address in the accumulator. Okay, load means we're going to load the accumulator into the address. Store means we're going to store the address into accumulator. Load means we load into the address. Load accumulator into something. Store means store something into accumulator, so be aware of that. Then this is load pair, store pair. AX means it's pair. Okay, it means that it's BC. Move register M means is HL, memory. Okay, move register into M, meaning that it's into memory too. For example, move data into M is HL, but data 8 is 1 bit. The bit data will be into lower. Okay, so the higher will be normal. For example, move M 0A, meaning that 0A is equal to 000A, where our HL, the L would have 0A and H would have 00, because last in, first out. Okay, then so what is the difference between immediate, direct, and also indirect? So immediate data transfer means it will directly into the register, any register including accumulator. Direct means data into memory location. For example, here address 16 means 210H, so sorry, 2100H, meaning I would be directly playing with the memory address. Whereas load indirect means maybe BC would be having 2100H, so load accumulator value into BC means if the accumulator value has 0A in it and BC has the memory location 2100, so the lower byte is 00, or we don't care low byte, now it's the memory location, so the OA will be stored in the memory location of 2100. Why? Indirect means data to memory which is in the register, so the memory which is in the register is 2100H, so load 0A into BC means load 0A into 2100H. Okay, so for load, store, move, our flag won't be reflected. Then we have arithmetic assembly language time, where in arithmetic we have add, sub, and increment, decrement. So add is add with data 8, add with register, add with carry. So this add has accumulator value with it. So add data 8 means we take the accumulator value and we add it with data 8. For an example, move A0AH, then we remit 8A01H, meaning that OA is now in accumulator. So add 01 means 0A which is in the accumulator need to be added with 01H, where we will be getting 0BH. Okay, so for add, so ACI means we will be adding accumulator value with a carry plus the data 8 or register. So DAD means a register pair. Okay, where we will be getting a memory, so we will be playing with memory, not carry. So ADI, ADD means only accumulator. AC, where there's a C, means accumulator plus with carry. DAD means we will take the memory which is HL pair with a register pair, maybe BC or DE. Okay, this will affect the flag. Now for sub, it's same. So this is data 8 a register, whereas sub BB or BI means we will have carry together. Okay, then this will also affect the accumulator and also the flag. Now for increment and decrement, the flag will be reflected except carry. For example, increment B, okay, maybe we name it move B00H, so increment B means it will become 01H, so the flag will be reflected. Why the flag is reflected? Sometimes in our code we will say move B00H, jump not 0 to loop 2. Now move B00H, if the 0 not 0 meaning 0 should not be 1, okay, jump not 0, so it will check the B. In order to check 0 or anything, it will refer to the flag, so it need to be reflected at the flag. increment register pair and decrement register pair will not be reflected in the flag. Okay, this will be reflecting the flag except for carry flag. So we have flag as such. So this is the what do you say, arrangement of the flag, so don't get confused. Then we have logical assembly language stuff. We have AND, OR, XOR, compare, rotate. So for AND, our auxiliary carry will be 1, our normal carry will be 0. Okay, so for AND we will be using accumulator value 2 and we will compare with the data 8. So if n data 8 means if our data 8 08H, we will take the accumulator value and end with 08H. Okay, so this is the register, which is we will take the data from the register, and this is data means it's immediately taking the data number that's being fed. So if n, accumulator carry will be 1, normal carry will be 0. If OR or XOR, accumulator will be 0 and carry will be 0 2. Sorry, auxiliary carry will be 0 and normal carry flag will be 0 2. In AND, auxiliary carry will be 1, normal carry will be 0. For normal complement, we will only play with accumulator value, no flag will be reflected. In complement CMC, we will only complement the carry. Okay, then for complement data, so in order to complement data, in order to complement register means complement B. So B, maybe it has 0AH, so you need to complement accumulator with the value of 0AH. Data 8 mean we will be directly given the data, where complement B means we need to refer to register B for what value it holds. Now what's going to happen is, if the accumulator value is less than data which is given or register, the carry will be 1. Okay, the carry flag will be reflected. If the A is equivalent to data, we will say 0, so 0 will be 1. If the accumulator value is more than data, your carry will be 0, your 0 will be 0 too. Okay, if accumulator is less than data, carry will be 1, your carry, the weight, because you are lower. Now if you are same, it's 0, it's tie. If you are higher, you don't need to carry anything, you don't need to 0 anything. Okay, so beware with that. Then we have rotate accumulator right. So RAR means you need to play with carry. So carry will be in front and then your A7 to A0 will be here. Now you need to rotate this, where your A0 will go to carry and carry will go to A7. So rotate accumulator left is also same. So right you turn to right, left you turn to left, but with the carry in front of A7. Now RRC or RLC, where there's a C, you won't be needing a carry. So what's going to happen is, if it's going to move to right, so the AO value will be in the carry, but the carry won't move into A7. Your normal AO will be into A7. So your AO will feed A7 and A7 will move to right, whereas the same AO value will move to carry. That's going to happen to RLC too. Here the RLC A7 is going into CY and the carry is being fed into A0, but in this case it's going to move to left, but the A7 is going to feed into AO and the A7 is going to move to carry. A7 in here means data bit 7 and A0 means data bit 0, because we have D7 to D0, okay, 8-bit numbers, so not be confused with any A there. Then we have branch, which is jump, call, return. So we have jump address 16, meaning that if our origin is 200H, then I have my code here, then I say jump to 8000H, whereas maybe I would say that origin 800H is call delay. So jump 800H should lead to jump to the call delay, but here this is a unconditional jump, whereas we have a conditional jump with flag reflected. So jump 0, jump not 0. Jump 0 means if the flag is 0, if the 0 flag is 1, then it means that we should jump, the jump will reflect. If the jump not 0 means the flag should be 0 for maybe GNZ loop 1, meaning that if the flag is 0, then only it will jump to loop 1. If the flag is not 0, it won't jump to loop 1. So JC means it will be seeing the carry flag, JM means it will see the sign flag, JP means it will see the parity flag. So I said that the flag are reflected here, so you need to be familiarized with that. Maybe move A0 AH, decrement B, jump N0 loop 1. So if the flag is 0, okay, the 0 flag, okay, LG loop 1, maybe loop so what's gonna happen is B is loaded with 0 AH, then it's gonna decrement 1, it will be 0 9H, then 0 1 it's gonna move into A, then it will check whether the 0 flag is lowered or not, but we will not put move A, we will maybe put out 0 0 H, something to be reflected. Maybe LED loop, then loop 1, so it will go here, decrement B would become 0 8H, then out again, then it will check whether the 0 flag is jump not 0, so it meaning that 0 should be 0, so it will loop again. So once 0 becomes 1, jump not 0 doesn't work, it doesn't loop, it will check the one beneath, so move C into something. So in for loop, so it means that in our normal for loop we will say that for x is equivalent to 3, x plus plus, or x should be less than 3. So we are doing the same here. Okay, so the decrement, if the flag is not 0, it will just loop back, jump back to here because it's not 0 yet. Okay, so that's the basic. Now the same goes to call also could be done the same way. Call 0, call not 0, call for carry 1, call not carry, call is sign, call not sign, call if the parity, call not parity. Return also same, return 0, return not 0, return carry, return no carry, return return sign, return no sign, return for parity, return no parity. Okay, so the same way, this is called as branch functions. For stack function, we have push register, push PSW, where register pair stands for BC, DE or HL. PSW stands for accumulator and also the flag. So pop RP, pop PSW. In and out is for IO, which we will be explaining further in the IO part. And these are all for interrupt. This is read interrupt, set interrupt mask, disable interrupt, enable interrupt mask. We will be talking this in the IO and also interrupt part, not to be worried. And then so for stack operation, as said before, last in first out. Okay, so in this case push HL, so we know that our stack pointer was 2009, so imagine 2009, 2098, 2097. So 2009 there was something in there, so our stack pointer was saying that 2009. Now we say that push HL, so we know that our lower bytes gonna sit, our higher bytes gonna sit here, our lower bytes gonna sit here. So push HL, so higher byte is 42, lower byte was F2. So the stack pointer, it's gonna go up here, so it's gonna say that 2097. As said, it's showing that 2097. Now this is for push means put in. Now we say that pop. Okay, so pop, now I'm gonna pop out. So how do I gonna pop out? So now I'm gonna pop out, I'm gonna say that pop into maybe BC. Now BC, okay, I'm gonna pop F2 first, then I'm gonna pop for 2, so it's gonna go down back. So when it's going down, it's going to show 2099. Okay, so for an example, if we are trying to swap, we will do this. So in order to try and swap, maybe if I am trying to swap the pair of BC with DE, for an example we do. Now imagine our stack pointer was same as 2099, so 2099, 2098, 2097 to great 2096, 2095. Okay, so imagine my BC was 4284, DE was 8384. so I am saying that push I am saying that push DE, so it's gonna be 8384, then push BC 4284. now I'm gonna say pop. Okay, I already push. I said that push DE. Okay, I said that push BC. now I'm gonna say pop DE, but what it's gonna do is it's gonna pop 84 and 42. so this is gonna be DE. then I'm gonna say pop BC. it's gonna pop out 84 and 83. it's gonna be for BC. now we see that the BC and DE is being swapped, but just using push and pop, which is last in first out concept. so this is for the changing method. Okay, so beware of that. Then okay, just now if you remember in the previous lecture, if you have followed the basic introduction to microprocessor, I have said that we need this instruction and all. so for instruction move BA, the logical is A is going to be into B, they have explained it, and the opcode for move is 47, meaning that the hex code for move is 47. Okay, then this is going to take 1 byte, where this 1 byte is going to take 4 clock cycle. No flags are reflected. now load pair data 16, so the data 16 is going to be in the pair. Okay, by 3 means lower, by 2 means higher. so the load LXI is 31 for opcode. it's going to have 3 byte because opcode and data 16 is a higher and lower, so 1 byte, 2 byte, 3 byte. so it's gonna have T4 state because the opcode have 4T state, high 3T state, and this 3T state because it's gonna read, then write is this okay, it's already have load, so write lah, load, stop, load, read. so it's gonna take 10. okay, no flags are reflected too. And I also mentioned that the stuff, so this is a 3 byte instruction. so the 3 byte meaning that 2000 plus 3, it's going to be 2003. so this is 2 byte instruction, so plus 2, 2005. this is a 1 byte instruction, so 2 is 6, so it's going to plus and plus. now so we know that each of these has 3 byte and a 2 byte and so on. To refer it, we need to refer to the machine code, which is the instruction set that would be given. Now in the instruction set, this is the code. So the opcode is 31, but see here, we are putting the lower byte first, then only the higher byte. Why? Okay, now what's going to happen is in a stack, we're going to put the high first and the low second. So last in is going to be first out. Okay, so this going to go in, this going to in, then only the lower will come out, then the high will come out. Same case but in a different format. So the max a byte can have is 3 byte. So in this 3 byte, what we're going to do is the first byte is always given to the opcode. The second byte is always given to the lower value, and the third byte is given to the higher value. In this case, so move A num1 may be 55. Move means 3A. So move B means 47. So this would be reflected in the instruction code. Okay. So this is a assembly that is exactly shown. So let's go through. So our origin is 000H, so LXI is 31H. Now 3F, FO is written first, then we have written 3F. Sometimes you are allowed to write without the H. In this case it's written in a perfect form, so no need to be stunned. So this is a 3 byte code. So the next one would be 0003 plus 3 byte, so it's there. So this will have AF, so it's a 1 byte code, so plus 1, it's a 4. This is also a 1 byte code, so plus 1. So this is a 2 byte code, so plus 2. So for port A we are using 80H. This would be explained in the IO video series, so no need to be worried. Then call delay, it's a 3 byte, so plus 3 will get 0AH. This is where you need to be familiar with the hexadecimal numeric. Then this is 3, so you're gonna get D, because A to B, B to C, C to D. Okay, then this is 2, you're gonna get F, then you're gonna go to 1 and 3. Okay, so this is how it's gonna work. So this is the memory, and also how the assembly language is being translated into hex code, and how the code is being referred. So I hope this helps. Thank you.